Okay. Anyway, visible? HDL model for combinational logic circuit. Here, first of all, what is this HDL? Hardware hardware description language. Okay. Anyway, you just read it. Hardware description language. Already we have done. We have done all the logic circuits. So how we are connecting AND gates, OR gates are 8 categories of the gates for designing of a language. So we are designing a logic circuit for the Boolean algebra. Boolean algebra is a language. We are designing a hardware circuits to design a language. That is what I intention. So generally the HL models are gate level modeling. This gate level modeling already we have done. We are connected all the 8 categories of the gates, correct? Yes or no? And implemented a circuit layouts. Next one is the data flow modeling. The data flow modeling is nothing but your data, it is scattered and it is displayed in a truth table as well as your K maps. That is a data flow modeling. Then behavioral modeling, especially marks behavioral behavior, how our output is depending on inputs. So that analysis also we have done this HDL model. And what are the applications for HDL modeling? So these are the basic applications for the HDL model. Circuit plan and reproduction. Here, whenever we are going to design any equipment or machinery, we need a circuit plan. That is what a circuit layout. So for everywhere we have designed a circuit layout. Yes or no? Yes or no? So that is the first way, because if you know the circuit layout, then you know how many gates are required, how many AND gates are required, how many OR gates are required, how many XOR gates are required. Everything you know, even you can analyze the cost analysis. So this designing of this particular device, this much cost is required. Are you clear? Then verification and testing. Yes, especially whenever we are going to design any model, after designing, if you test, any failure is going to happen, then the cost is going to waste. Yes or no? That is why you design a circuit. So you are testing with inputs. Earlier, it is producing output or not. Once it is doing, then you go for the production. So before production, this model, whatever we are designed a layout, that will help to the engineer that is a successful model or which it is going to produce. Are you clear? And coming to FPGA plan or ASIC plan, it's the same. Your structure is nothing but the plan of the architecture. What are the inputs we need to consider and how many inputs are going to work? Those inputs are going to involve or not. So everything it is visible in your structure. Next, digital signal, digital sign handling. Yeah. So whenever we are designing a circuit, the digital sign means digitally we need to connect. Actually, one software is there for this. There is no time. That is why I am not going to tell. Most softwares are available. You can connect your gates and you can get in, you give input and it will be generate output. So that digital signature way also we can do it. After this first unit, I will give it to you one exercise on that software. You can do it. And high speed response. Yes. Always we are trying to produce the data more speed. That is why this, especially the last topic, multiplexers are going to help. Here, unnecessary usage of inputs we are going to avoid. If we are avoiding unnecessary usage, then what is going to happen? Only those lines will be on. If those lines will be on means the data will be more fast. So you should be analyze all these gates and the finally the multiplexers you should design. This is the final statement I am going to provide, that is a design a multiplexer for every problem. The starting whatever we are designing, these are all just understanding how circuits are going to design. Finally, you should be design a multiplexer for every problem. If you design like that, your maybe the machine or maybe the device is more speed and it will produce correct data, so that, and power consumption also less. So this is what exactly the hardware design